Welcome to All This Math. This is Professor Parker, and what we're about to do is some work with the Pythagorean Theorem, a squared plus b squared equals c squared, and we're going to use it after we read this word problem, because one of the applications of a squared plus b squared equals c squared is in word problems, and we should become comfortable with word problems because that's when we really start to use math in real life situations. A lot of people often ask the question, when am I ever going to use this stuff? Well, the examples that you get in school a lot of times are found where you would use this stuff in real life or that reflect real life situations are often found in word problems. But one of the problems is a lot of times we don't understand the word problems. So then it just seems like, we're just doing unnecessary work. But the math you do is very necessary. But in order for you to understand when it's necessary and how to use it, we're going to have to understand word problems. We can't be intimidated by word problems, okay? So the first step, of course, in any word problem is you just read it. We just read the word problem, try to get an understanding of it, right? Just as if you were in English class or English language arts class or literature class, you just read it, all right? So let's read it. It says that the bottom of a ladder must be placed 3 feet from a wall. The ladder is 12 feet long. How far above the ground does the ladder touch the wall? All right. Now, normally what I would tell you is whenever you encounter any word problem to read it at least 3 times. Read a word problem at least 3 times. All right. The first time you read it, it might not make a lot of sense. The second time, it'll start to make a little bit more sense. The third time, it'll make even more sense. Also, sometimes what I also recommend is for you to draw a diagram, which is what I'm about to do in a minute. Because they're talking about ladders and walls and 3 feet this and 12 feet that and how far above the ground. And, you're going to try to visualize that in your head anyway, but it's even easier if you just visualize it on paper. So on your own paper, you should draw a picture. So I'm going to draw a picture. All right. We're talking about a ladder leaning up against a wall. All right. So we got a ladder. We got a wall. And so this is what I'm going to do. I'm assuming that this ladder is going to be used on leaning up against the outside of a house. All right. It could be inside a house, but let's just assume it's leaning up against the outside of a house. So what I'm going to do is I'm going to draw the outside of a house. So I draw a vertical line. I draw that. And I draw that. You could try to get a little fancy, put some windows. It's an upstairs window. Might be a downstairs window. Maybe the door's over here somewhere. All right. So that's like the wall, right? This is the wall right here, right? Now, keep in mind that this wall is a vertical line. The wall is a vertical line. And whenever you see a problem like this, this is one of those, a squared plus b squared equals c squared problems, right? When you talk about the ladder, we know that we're going to use that formula, right? Pretty much 9 times out of 10, when you see a question like this, you're going to use a squared plus b squared equals c squared. So just also make a mental note of that as well, because that'll help you too. All right, so now we take the information from the word problem and we draw it, right? We take the information from the word problem and we draw it. Now, the first sentence says the bottom of a ladder must be placed 3 feet from a wall. So here's the wall, and the bottom of the ladder is going to go down here somewhere, right? So I'm going to draw a point like out here, and I'm going to say that this is 3 feet. From here to here is 3 feet. So from the wall to the point where the bottom of the ladder is going to be 3 feet. All right. Now, the ladder is 12 feet long. So the actual ladder itself is 12 feet long. From the bottom of the ladder to the top of the ladder, from one end of the ladder to the other, that's 12 feet long. So that means, of course, the bottom of the ladder is going to go right here. How do I know that? Because the first sentence says the bottom of the ladder must be placed 3 feet from the wall. And here's the wall, and here's the ground where the ladder is going to be placed at. So what I'm going to do is I'm going to draw like a line like that. This is my ladder, right? This is my ladder. And since this ladder is 12 feet, I know that this length is 12 feet. And if you haven't caught on yet, you notice what's about to happen is I'm about to draw a right triangle. Basically, the ladder is part of my right triangle. The length from the wall on the ground, the length from the wall to this point is another part of my triangle, right? Now, in these problems, we assume that the ground is horizontal or flat, right? Flat and horizontal. And we assume that the house or the side of the wall is vertical. So when a horizontal line crosses a vertical line, that creates what's called a 90-degree angle or a right angle. So we can draw our right angle symbol right there. All right. So now we have a right triangle. And since this is the right angle, we know that this is the hypotenuse. If you're not familiar with what a hypotenuse is, get familiar with a hypotenuse, because the hypotenuse is a couple things. It's always the longest side in any right triangle, right? And it's always located across from the right angle. So here's the right angle right here, and here's the hypotenuse right here, across from the right angle. All right. Then the question is, how far above the ground does the ladder touch the wall? Here's the ground, right? And here's where the ladder touches the wall, at one point, right here. That point right there. Now the question is, how far above? So what's the length from here to here? That would be the other leg of the right triangle. So now we know what we're trying to do. We're trying to figure out the length of this leg. And in order to figure out the length of this leg, we're going to use, as I told you before, a squared plus b squared equals c squared, right? The right triangle formula, okay? A squared plus b squared equals c squared, right? Now, we know what the hypotenuse is, so we know that that's c. The hypotenuse is always c in the formula, right? Within the formula, the hypotenuse is always c. So I know I'm going to replace the letter c with 12, because 12 is the length of the hypotenuse, and the hypotenuse is always c. Now, I know one of the legs. I'm going to figure out one, and I know the other one. Now, in case you're wondering, which a lot of people wonder, well, which leg is A and which leg is B? That's an excellent question. But the answer to that is, it doesn't matter. It doesn't matter. Either leg could be A, either leg could be B. What I'm going to do is, I'm going to make A 3 feet. I'm going to make A equal to 3. And then I'm going to make this leg B. And it doesn't matter. If in your own work, if you wanted to make the missing leg A, and then the other leg B, 3 feet B, that's fine too. You could do that too. You'll end up with the same final answer. So I said, right, what did I say? I said, yeah, I was going to make A 3. So I replaced the A with a 3. The exponent is still there. Then I write the plus sign. The B is still there. The exponent 2 is still there. And now I'm going to solve for b squared. Now the way I solve for b squared is I simplify everything I can. So I simplify 3 squared. And again, I want to be clear with you. I want you to be clear. 3 squared does not equal 3 times 2. It does not equal 3 times 2. 3 squared equals 3 times 3, which is 9. So this becomes 9. And then we have a plus sign, and we got b squared. Now over here, similarly to 3 squared, 12 squared does not equal 12 times 2. It equals 12 times 12. And if we have our multiplication facts memorized, from at least up to 12 times 12, we should know that 12 times 12 is 144. So now, we're going to subtract 9 right here and subtract 9 over here because we're solving an equation. We're still using our algebra steps. 144 minus 9, I believe that's 135. And then we're going to isolate b. We're going to get rid of this exponent. The opposite of squaring something is taking the square root of something. So that means we're going to take the square root of b squared, which is just b. And we're also going to take the square root of 135 because when we solve equations, whatever we do on the left side of the equation, we also do on the right side of the equation. So this radical sign and this exponent basically cancel each other out. So that leaves me with just b. Now, 135 is not a perfect square. So at this point, you take your calculator, right? Go to your calculator, you type in 135, hit the square root button, and you'll get something like 11.6. So that means that the length from the ground vertically up to the point where the ladder is leaning up against the wall of this house is 11.6 feet. So this leg right here is 11.6 feet. And that's how you do it. So whenever you see a question like that, whenever you see a question dealing with a house, a ladder leaning up against something, those are one of the classic Pythagorean Theorem word problems. And this is how you do it. I highly recommend you draw your picture. Everybody doesn't draw a picture and draw a diagram. That's fine. Sometimes you'll be given a diagram. Sometimes you won't. I highly recommend you draw your own diagram though. All right. So that's how we do it. So when you see a word problem like this, just remember that You want to identify all your information. You want to read the word problem a couple times. You want to understand all the information in the word problem. Like I said, I recommend you draw a diagram so that way, you can have something to visualize, and that's less for you to think about in your head because it's right there on your paper in front of you. And then you go to the formula and make sure you replace the letters with the correct numbers. Make sure you always make your hypotenuse C. The hypotenuse always has to be C. A and B are the other two legs of the triangle. So this leg and that leg, right? And it doesn't matter which is which. You could do A and B or B and A. It doesn't matter, right? But the hypotenuse, that matters. It must be C. All right? Now, if you have not subscribed to the channel, please go ahead and subscribe to the channel. Also, turn on the notifications because I'm dropping content and I'm putting out content on a regular basis or weekly basis. And, it's quite likely that I'm going to make a video that you need anyway, in your own studies. All right. Tell some people about the channel. Tell some people about what we're doing. Share the videos. Tell some other people about these videos. All right. And what we're doing over here at All This Math. Okay. And as I always say, please remember that there's all this math all around you. Peace.